Good morning, children. Welcome to the online classes of our Regina School. I am your Jagadish Master. Children, in IIT Chemistry, we have completed 6 synopsis. Out of that, 4 synopsis practice bits we will see now. Okay, my dear children, this is practice sheet 1, and we will have all the questions related to first 4 synopsis. Okay, see here the scientist. First question: the scientist who suggested a method of representing elements using the English letter is Berzelius. Okay, he is the scientist who suggested the method representing the elements. See here, hydrogen. So what is the how we will represent this? H. Second one, helium. How we will represent C? He. Okay. Oxygen. How we will represent this? O. Like this, representing the elements using English alphabetic letters is suggested by this method of representing the English alphabet letters using first letter or first 2 letters. Like this, we are representing the elements. So who suggested this method? J.J. Berzelius. Next, short form representation of an element known as symbol. Okay, what do we call short form representation of an element? Symbol. Next, the combining capacity of an element is called valency. Okay, what is valency? I told you. Combining capacity of an element is called valency. See, here one atom is there, that is hydrogen. Here another atom, oxygen, is there. Now valency, what is valency actually? Here only one atom is there. Okay, atomic number of hydrogen is 1, oxygen atomic number is 8. Now see, this is the nucleus, first orbit this is, so there is only 1 electron, atomic number is 1 now. So in nucleus 1 proton will be there, so there only 1 in the first shell. But in the first shell, how many electrons should be there? 2 electrons should be there, but how many are there? Only 1 it is there for hydrogen. So the valency of this hydrogen atom is 1. What about oxygen? See, in the first shell 2 electrons will be. What is the atomic number? 8. That means 8 electrons you have to distribute. 2. In the second shell, how many it will be there? Okay, 8 has to be there, but how many are there? 4. So 3, 5, 6. Okay, in second orbit 6 electrons are there. What is the valency here? 2. Okay, 2. How many has to be there? 8 should be there, but how many are there? 6. That means valency of oxygen is 2, valency of hydrogen is 1. So in order to combine these elements, we need to know valency. That means now if you have 2 hydrogen atoms, oxygen can be combined with this, we will get H2O. Okay, now like this, combining capacity of an element is called valency. This is the definition of valency actually. Okay, next, the number of protons present. See here, the number of protons present in the nucleus of atom is called atomic number. Okay, what is atomic number? Atomic number is equal to number of protons present. Okay, this is the nucleus. In this nucleus there will be neutrons and protons. Okay, in this nucleus there will be neutrons and protons, isn't it? The number of protons present in the nucleus of an atom is called atomic number. This is also a definition of atomic number. See next question. The name of the ion of a variable valence element with higher valency in compound ends with IC. Okay, see here. Generally, you know what is valency, we have discussed now only. So again this valency is having two types. That is, some elements will have higher valency, some elements will have lower valency. Okay, now lower valency elements are ended with OUS. Higher valency elements are ended with the name IC. Okay, higher valency elements are ended with the suffix called IC. Lower valency elements are ended with the suffix OUS. So here the question, see here the question, the name of an ion of a variable valence element with higher valency in compound ends with IC. You know what is compound? H2O is a compound, H2SO4 is a compound, like that 2-3 elements are combined. Next, the Latin name of sodium is natrium. What is the Latin name of sodium? Natrium. Okay, you have to read the names of the elements. Some are represented with based on the country or laboratory in which they were invented. Some are represented with scientist names. Okay, some are represented with Latin names. In that, sodium is represented with a Latin name. So what is the Latin name of sodium now? Natrium. So symbol of sodium is Na. First two letters we will use. Okay, next, the element curium was invented by, see here spelling curium. See the name curium, Madam Curie. Okay, curium is one element in the periodic table. Who invented this? Madam Curie. Okay, next question. The valence of nitrogen is, so I told you valency of nitrogen. How to find the valency? Based on atomic number. What is the nitrogen atomic number? 7, isn't it? So nitrogen atomic number is 7 now. Now see here, this is the nucleus, first shell, 2 electrons you have to represent in the first shell. Next, okay, second shell, this is K shell, this is L shell. In L shell you will have 8 electrons, 2, 8, 8, 18, like that it will be there. So in first shell we will have 2 electrons. In the second shell, remaining, if out of 7, 2 electrons we have given to first shell. Still how many will be there? 5 electrons. So 2, 2, 4, 5. Okay, 5 electrons will be given to the second shell. So how many has to be there in the second shell? Actually 8. How many are there? 5. So there are only 5 electrons in the second shell, but how many has to be there? Okay, how many has to be there in the second shell? 8 electrons. So that means valency of nitrogen is 8 minus 5, that is 3. Okay, 8 minus 5, 3. Okay, how many has to be there? 8. How many are there in the second shell actually for nitrogen? 5. That means valency should be 3. Okay, what is the valency of nitrogen? 3. Next, atomicity of an element tells about the number of atoms in one molecule or compound. Okay, now What is the atomicity of an element? Number of atoms in a one molecule or one compound. So this is the definition of atomicity. Okay, next, mass number of oxygen. What is the mass number? See, atomic number of oxygen is 8. Okay, atomic number means number of protons. So Z atomic number is represented as Z. Okay, now number of protons will tell you atomic number, but what is we want mass number. Okay, mass number means number of protons plus number of neutrons. Okay, so according to mass atomic number, what is oxygen atomic number? 8. That means number of protons is 8 plus number of neutrons. Number of neutrons are also 8 in the oxygen. So total we will get 8 plus 8 is equal to 16. Okay now, so see here, the mass number of oxygen is 16. Okay now, it is there now in the option. Now, which of the following element exhibits diatomicity? What is atomicity? Number of atoms in one molecule. So diatomicity means 2 atoms. Okay, which will exhibit, chlorine will exhibit the diatomicity. How we are telling? See here, Cl2, that means 2 atoms. Okay, atomicity of chlorine is now 2. Cl2 means we can write Cl2 now, chlorine. If we are able to write Cl2, then it is diatomicity. Okay, next, number of protons and neutrons in an atom is called, I already told you, number of protons and neutrons. So in the case of this mass number of oxygen, while we are discussing this question, what is mass number? Number of protons plus neutrons. The same definition he is asking in the 12th question, that is mass number. Okay, number of protons plus neutrons will give you mass number. Why we are not considering electrons? We are not considering here electrons because electrons mass is very less, that is 1/1840 of mass of protons. Okay, next, the name of the ion of a variable valency element with lower valency in a compound ends with OUS. See here, the name of ion of a variable valency element with higher valency in compound ends with IC, higher valency. Then what about lower valency? OUS. This bit already we have discussed. The symbolic representation of magnesium. How we will represent the magnesium? Mg. Okay, so symbolic representation of magnesium is Mg. Okay, you need to study the symbols. See here another bit. Which of the following elements exhibit monoatomicity? Okay, monoatomicity. Diatomicity means Cl2, I told you. See, oxygen you can write O3. What about mercury, Hg? Only 1 you will take. What about copper? That is Cu. The symbol of copper is Cu. So you will write only 1 Cu. Okay, what about calcium? You will write only 1. Okay, Ca. Symbol of calcium is. Okay, next, which of the following metals exhibit variable valency? Variable valency. So variable valency is exhibited by silver and iron. How you are telling silver and iron will exhibit variable valency? So whenever a variable valency is there, how you can write this ion? Ferrous, ferric, isn't it? Higher valency you will write ferric. IC will, see, I will write here. So an element ending with, see, ferrous, nothing but iron. not iron, ion it is. So ion. Now if an element having variable valency, that is higher valency and lower valency, two valencies should be there, then we can say that element is having variable valency. So now how can we write this ion? If it is having lower valency, we will write ferrous, OUS. If it is having higher valency, ferric. What about silver? Argentinum, Argentinus. Okay, Argentinus, lower valency. Are we representing like this or not? That means silver is also having, what is the symbol of silver actually? Ag. So from in Latin name we will call silver as Argentinum. From Argentinum we will take Ag symbol. Okay, silver symbol is Ag. In Latin we will call it as Argentinum. So from that Latin word we are taking the symbol as Ag. We are writing this Ag as the symbol of silver. Now Argentinus, that means it is having lower valency. Okay, so from the given options, okay, silver and iron will exhibit variable valency. Okay, next, which of the following elements named as country? Okay, ruthenium. Okay, ruthenium is the country name from Russia. So it is derived from the country. This name of the element is derived from the country's name, that is Russia. So ruthenium is the example. Okay, next, which of the following elements are name of the scientist? Okay, which of the following elements? See Mendeleev. See here, which of the following elements are name of the scientist? Nobelium, Einstein, Mendeleev. All these three are okay, all these three elements are derived from the name of the scientist, that is Nobel. Okay, great scientist, that is Einstein. Here the scientist name is Mendeleev. Okay, all these three options are answers. Next, hydrogen, oxygen, carbon and sodium are elements. Elements cannot be, what is the statement 2? Element cannot be split up into two or more simple substances, isn't it? So hydrogen, oxygen, carbon and sodium are elements. Okay, out of 118 elements, hydrogen, oxygen, carbon and sodium is also among them. Now elements cannot be split up into two or more simple substances. Okay, is it correct? No, actually elements can be split up into atoms. Atoms can be split up into electron, proton, but atom is the smallest, so you can split it. Okay, so what is our answer? Statement 1 is correct and statement 2 is incorrect. Okay, this is our answer. Next question. A symbol represents short form of an element. So the scientist J.J. Berzelius suggested this method of representing element using English letters. A symbol represents a specific element and one atom of an element. So the symbolic representation of mercury is mercury. How you will represent? Hg, symbol of mercury. You have to study the symbols. Okay, you have to study the atomic numbers, okay, symbols, all these things from the periodic table, my dear children. The symbol He stands for helium. What is the symbol for helium? He. Okay, what is the symbol for hydrogen? H. Okay, what is the symbol for lithium? Li. What is the symbol for nitrogen? Ni. N. Okay, next, identify the correct symbols for the following elements. Identify the correct symbols for the following elements. So calcium is represented as Ca. First option gives you Ca, second option, third option, fourth option. In all four options, calcium answer is correct. What about chlorine? Cl, Ch, that means it is wrong. Here it is Cl. How the letter? I already told you, in representation of symbols, second letter should be small letter. Okay, second letter should be small, but how it is capital letter he has given, so it is wrong. Fourth option Ce, so it is also wrong. Only third option it satisfies. Okay, chlorine representation is Cl. First letter should be capital. What about second letter? Small letter should be there. What about beryllium? Be. Okay, third option is correct. See here, atomic number of the elements. You have to study the atomic numbers of these elements: chlorine, silicon, sodium, argon. All these atomic numbers you need to study from the periodic table. Okay, thank you.